Okay, welcome back. We're on page 354 talking about the difference between authorization and authentication. So authorization is all about, what permissions I have to do what. I will tell you, for example, I'm a developer and I write applications, and occasionally I want to connect to a database that I'm writing an application with. So I'm writing an application that connects to a database, and at the beginning of this writing process, I may have quite a few bugs. And so I absolutely specifically do not want write permission on that database while I'm working on the application. And only when I feel confident, okay, I think I've got it, then I go back and add my permission to be able to make changes to the database. Because otherwise, geez, no telling what would happen, in the early days of a project. So, don't think of read and write permission is like being punitive. Sally has write permission, but I don't. That's not normally the way it works. In some cases, I go up to the administrator and say, please remove my write permission from this database because I don't want to be responsible for making any changes or messing things up. So it's not always bad. Okay. Let's talk about the ways you could do authentication. So, name and password is a typical way of doing it, but there's a lot of others. There's these, what's called a single factor, like a name and a password. In other words, all you have is something that you know. So something I know could be easily stolen. I could write that down, or somebody could torture me and get the password, right? So things that I know, like, password, that's okay, but not great. The second factor would be something that I have. So, for example, I have a CAC card, so I physically have the card, and I know the PIN. So it takes two pieces of the puzzle to make it work. And even that's not perfect. If somebody stole my wallet and grabbed my debit card, they could go to the ATM machine, and because they physically have the card, but they don't know the PIN. So, it takes two to tango, so I'm kind of sort of protected. Third factor authentication would be something that you are, like a retinal scan or thumbprint or something that's kind of unique to you. So that means, third factor means you are physically there, you physically have something, and you know something. So three. And by the way, Hollywood almost always gets this wrong. They'll like doing an iris scan, right? They'll walk up to a little device and get their iris scan or thumbprint, and the door opens. No, that's single factor authentication. Nobody does that. It's almost always in combination of something else. It's a password, a PIN, a card, and this third factor, right? Not third factor alone, because thumbprint alone isn't good enough. Iris recognition is not by itself is pretty dumb. That's just as bad as having any one of the single factors. Okay, I gotta tell you, I watched this goofy movie called Alien Resurrection, and in this movie, the factor 3 was the odor of your breath. I'm not kidding you. So they walk up to this thing and go, and the door would open. Okay, crazy, right? I don't think that exists in real life, but hey, that's what they have. Okay, so next they talk about best practices for passwords on page 355. So you've probably heard this from other people. You got to have numbers and letters and special characters. You got to have uppercase and lowercase. And then the length, it used to be that a password length of 8 characters was kind of sort of okay. And now, big businesses and like the government require, 12 to 14, 14 to 16 length, and big lengths of these passwords. One of the other rules is the password can't contain any real words in there. I mean, you can't have kumquat in there, or Charlie Brown, or you can't have anything that is a legitimate word. No dates, no groupings of numbers so that they form dates. There's the thing called a dictionary attack, where people just take a listing of words, a dictionary, and just run it through trying to find, people who have passwords called, passwords called 1234. The other one, of course, is you should change your passwords regularly. Now, is it possible for you to kind of overdo that last rule, where you change your passwords so often that it makes it worse? Let's say, think about your own environment, at a work environment. If they said you had to change your password every 6 months, you'd go, dang it, okay, I guess I could do that. And so it wouldn't take you very long to remember your new password every 6 months. But if I said, we're going to change passwords every 6 days, you'd probably think, why bother to remember that? I'm just going to write it down and hide it under my keyboard. So yeah, you can't overdo it. 30 days, that's a little much. That is a little much. You might think by changing, reducing the time to 30 days for a password is going to increase your security, and you'd be wrong. Dropping it down to 30 days is actually going to make your security worse, because everyone is going to write down their password somewhere in their cube. Okay, it's going to be on a sticky note. It's going to be in their desk drawer. It's going to be somewhere. So don't think that tightening security to the point of absurdity is actually going to make things better. Okay, so one more thing. Let's talk about authorization again. Dang it, gotta make that stupid thing go away. Okay, cool. So authorization is, I do not normally log into my machine with admin rights, at least not anymore. And why is that? Well, because if someone could get a hold of you being, you walked away, and your machine was still logged in, they could do anything to the machine. They could affect any application anywhere in the machine. If, on the other hand, you were just an ordinary user and you walked away and somebody came up, they could wipe your files out, but they couldn't wipe anybody else's files out. They couldn't mess with the Windows operating system at all. So it limits the amount of havoc that they can create by having you not be an administrator unless you need it. So don't ever be in a scenario where you are an administrator and so you log in as an administrator account kind of on a routine basis. There's some other stories. Let me just give you some other stories. Again, I'm a developer, and I've been in one of those scenarios where I've written an entire application and it works just fine on my machine, and so I send it out to the world, and they say, well, I can't get it to work. And why? Because I had permissions that they didn't have. Yeah. So, don't artificially elevate your own permissions. That causes troubles. Okay. On page 355, they finally start talking about the integrity piece. So now we're talking about the incoming integrity. And so and remember, integrity is 2 parts. One is you can't alter any data. That's one. And the second is you can't later claim that you didn't send it. So one part of integrity is you can't change anything without getting caught. And the other is you can't non-repudiation. You can't say, well, I didn't send that. Like, oh, yes, you did. Okay. The first thing I talk about is firewall. So incoming stuff. So integrity is all about making sure that the stuff I have doesn't get messed with. So no one catches a piece of information in transit to me. And, the example I always give is HR sends an email to a boss saying, hey, you need to give Bob a $100 bonus. And so Bob sees this email flying through the network and adds an extra 0. And so instead of getting a $100 bonus, by the time the email arrived, it said $1,000 bonus. Cool, huh? Okay. So that's what we're trying to do. We're trying to make sure that nobody messes with stuff. The first device, the first thing they talk about is this firewall device. And so the firewall actually could be a computer, although that's not very common now. Typically you go buy a dedicated firewall, or you buy a very expensive router that has a firewall capability break into it. So the bottom line is a firewall is designed to separate the good guys from the bad guys, or the trusted network, the things that I do trust, and then the untrusted network. So it's just a thing that fits in between, so that incoming packets, and again, we're talking about incoming in this particular chapter, or this section rather. Incoming packets, they look at three things. They look at the source address, IP address, the destination IP address, the protocol being used, and then the port number, right? So for example, let's say for example, I have a web server over here, and so this guy would say, I'm going to allow port 80, because that's the one for web services. I'm going to let that through, but port number 200, I'm not. So I just arbitrarily pick which ones of these combinations of things that I want. Okay. So there are some rules, and sometimes they're called an access control list, an ACL. And so the rules are basically just what I just described. You could have a rule that says, I will allow any incoming packet, so in other words, who cares about what the IP address is? I can put an asterisk there. Any incoming packet, as long as it's TCP and port 80. So any TCP, so incoming, any TCP, port 80, allow. So that's kind of the rule. You could have a deny rule that basically says, I'm going to block all packets from, some IP address, 123.123.123.1. Those are bad guys, and I'm not going to allow any packets from them whatsoever. Now, you do have to kind of set this thing up in a hierarchy, like whichever rule applies first. So most people deny everything and then slowly start adding back the things that they want. So deny by default and then add later. Okay, so it kind of works like layers of a cake or layers of paint or something. I'm going to show you the Microsoft one. So if you just go to your control panel and go to the firewall, it basically shows this, and there's some advanced settings, and the advanced settings are going to show you what those rules are that I just described. So for example, let's just pick some inbound rules. So here's one for that is turned on. So Firefox, for example, has something. It has UDP for any. Okay. So Firefox is got enabled and allow and any port and any IP and blah 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 blah. So Java, what it's allowed to do, it take all these things. Here, let's use a port 80 one here. That's always a good example. So that one particularly is turned off, so that's probably a bad example. But anyway, the idea is to have these things that are available, and it basically tells you what is allowed, what incoming traffic is allowed to come to your machine. Now, in this particular case, this firewall happens inside your computer, so it's not the same as this guy. This is a physical device. So the rules are almost the same. So typically you have a real physical firewall, and each one of these devices have their own firewall. So you've got some pretty good stuff going on there. Cool. Hey, let's see what Sakuni is up to. Oh, sorry. Oh, man. I thought I'd hit that. Okay. So, firewall rules. Let me just minimize that and get back to where we're going. All right. So, once again, the philosophy for firewalls is start with denying everything. At this level, deny everything and then poke a hole in the firewall for only the types of traffic that you want. For example, I have to poke a hole for port 80. I have to poke a hole for port 25 for email, but nothing else. So start with deny everything and then selectively figure out what it is that you do want to have through. Okay, this is a good place to stop for the 15-minute mark. We'll pick this thing up again in just a few.